I have the honor to guide you through this after-lunch session. In about 30 minutes, you will know why you shouldn't get too comfy on biogenic uptake. And I mean, with biogenic uptake, I will talk about the biomass content in products that you might use or process during your supply chain. My name is Martina Bender. I am responsible for product sustainability at the EGGER Group. So many exciting information have already been given during this conference, so it's hard for me at the latter part to add something new. So I'm taking this opportunity today to tell you about the challenge in evaluating biomass-derived carbon within the supply chain. As I have seen here, is that many of you have already recognized that it's fundamentally important to address one's Scope 3 emissions and to engage in dialogue with the suppliers. And perhaps your suppliers have also presented you some exciting new type, so-called next generation types of products and material in which the fossil raw materials are replaced by biomass-based raw materials. And we, as the wood processing industry, we can show you some excellent examples to illustrate this difficult and unfortunately sometimes kind of counterintuitive topic on a real-life example. EGGER is a wood processing industry, and we started production in 1961, and we have since grown to an international manufacturing company for wood-based products. Our parent plant is in St. Johann in Tyrol, but I'm coming from the plant at Wismar at the Baltic coast. Our product areas are furniture and interior design, building products for construction use, and flooring materials. We have various target groups ranging from furniture industry to retail, trade, architecture, to the DIY sector. And we are not the first family-owned company here at this conference. EGGER is now in third generation, and this year was very exciting for us because we have a generation change in this year when the grandson of the founder has taken the helm in group management. Our vision is to be the leading brand for wood-based solutions, and I want to show you how our value chain is working, that you get an impression what it actually means when I talk about wood-based products. So we start with trees in a sustainable managed forest, and those trees are cut in a sawmill into wooden boards, and at the one hand we have those boards, and the other hand there occur byproducts like wooden chips or sawdust. And these byproducts we can kind of bake with the help of a lot of pressure and heat and some glue in very huge presses. We can bake them to new large format wood-based materials, so-called chipboards or fiber boards or oriented strand boards. Those boards, those new boards, they can be used as a raw material, but they also might be refined in further process steps, for example, by pressing on a decorative surface made of resin-impregnated paper. And then we get such kind of decorated coated chipboard, and I'm sure that you all have seen such kind of product in your kitchen, where it forms the kitchen corpus or the front doors. Within our industry branch, we are already very far along in terms of transparency and data availability. We report our carbon footprint of our products, and we indicate the proportion of renewable and recycling materials that are used in the manufacturing. For example, this eco-fact where you can see the tree and the little oil barrel, we say that 85% of this product is made from renewable resources, but everyone who is able to calculate is aware that there are still about 15% fossil-based material in such kind of chipboard. When we have a look at our group-wide sustainability performance in the last financial year, we can have a look into our annually sustainability report. It's a very huge report. It has about 150 pages. But here are some key figures where you can see that 63% of the wood that we use already comes by byproducts or recycling. That 85% of the materials that we use in our manufacturing are made of renewable raw materials, and that our products have stored within the past year about 6.5 million tons of CO2. That's quite impressive. And I think this is a fantastic takeoff point that some other industries might be jealous of. And indeed it is. Handling tons of wood from sustainable forestry has a lot of advantages. But as so often I look into the details never hurt. And so we offer LCA data for most of our products. We offer EPDs for 81% of our products. That's quite a lot. And those EPDs, Environmental Product Declarations, this is a special LCA format for building products with a very high standard in data quality. And the great thing about this data is at first that we have it already. And the second great thing is that the standards of this assessment is very high, so that the core indicator, global warming potential, is shown in separate sub-indicators within those EPDs, so that we can see the biogenic share and the fossil share of this global warming potential separately. And I show you now why this is important. And I start with a very simple example. If you remember yesterday, Kasia from IKEA, when she said that they are selling simple products. And so now I'm talking about a super duper simple product, just to get you into the topic. So we start with our timber. Timber is 100% wood. It's just a tree that you cut into boards. So we have material that is 100% renewable. It has 0% recycling content. And it has only one component. But we have also, for this simple product, we have LCA data. We have an EPD. And now I will show you just a screenshot of this LCA result table. Actually, this result table is huge, and I just cut out the core indicator for the global warming potential. And you can see that it has several lines. In the first line, we find the global warming potential total. For wood, pure wood, it has a very high number with a minus in front. That means that it has a negative carbon footprint in the total. In this total, and the total means that is the sum of the subcategories you find below. So if you take your calculator of your mobile phone and count the other 3 lines together, you will get the total we have in the first line. So the global warming potential total is the sum of the other subcategories. And when it's negative, that means that there must be a lot of carbon stored in the product, and we could say, okay, our timber is quite good. We're done. Nothing to do here. Everything is fine. But now we have a closer look on those other subcategories, where we start with the fossil fuels. And we have a number of 101 kilogram CO2 in this line. Those emissions occur during harvesting activities, transport activities, the processing in our plant because we dry the wood, and the machines from cutting, they also use some electricity. And so in sum, we have fossil emissions for those natural material of 100 kilogram per square meter. And the next line, we have biogenic emissions. Again, a very big negative number, because here we find as emission, because the plant grows and takes up the carbon from atmosphere, we have a negative emission. That's why we have a lot of negative emission in the biogenic part due to the uptake by the tree growth. The last line is about land use and land use change and the emission that occur there, but they are quite small, and I will ignore them for the rest of this presentation. So we will focus on the global warming potential, which is composed of fossil and biogenic emissions. And at this point, I would like to talk about the special feature of accounting biogenic carbon according to the ISO 40067 standard. In this approach, actually the temporary carbon storage is not taken into account, and wood is such kind of temporary storage, because although carbon is stored in the material, but someday it will be released either by burning it or if it's rotten, but the day will come and the carbon will be released back to the atmosphere. But this is not the problem at all, because the amount that will be released is the same amount that has been taken before during growth. And that's why this biogenic carbon is regarded to be neutral. It's kind of a zero-sum game. It's the same amount that comes from atmosphere, then we use it for some years, and it doesn't matter if we use it for 5 years, 10 years, 50 years. Someday it will be released, but that's fine because it's zero in sum. So this negative emissions we have seen in the table before, they are neither credited nor debited somewhere. So we can't, because the share is assessed to be neutral, it has not a relieving effect on the other emissions. Fossil emissions, they have occurred. They happened, and you won't make it better to have some biogenic cycle of carbon beside that, because you can't make it undone. And a product with fossil emissions is not climate neutral or climate negative. And now we switch back to our timber. And this product we see here with this 100 kilogram of fossil emissions, those 100 kilogram, they enter our customer scope 3 emissions. So if Hornbach is buying our timber, this is the footprint that enters there as a burden into their scope 3 emissions. And on the other hand, we as EGGER know exactly where our homework lies. So we know where we still need to improve our processes on our way to net zero. So let's come to a first conclusion: the danger of looking only at the sum value. A high proportion of biogenic material tempts to comfort oneself on a low or even negative global warming potential total. But the risk here is to ignore or not to address, to ignore the fossil emissions and not to address change in our own processes or to foster changes in our previous chains. The fact that the use of wood does not have a relieving effect on the scope 3 emissions or on the scope 3 burdens may seem to be unfair to some people. They say, why isn't we are using so much wood? There must be kind of award or something like that. And when you say, no, it's calculated as 0 because it's neutral and this is good enough. And on the other hand, these biogenic emissions that we that occur in our own biomass plants when we are burning old wood, they are also not taken into account as a environmental burden because they are not fossil, they are also biogenic. So I hope you are now ready for the next step. We come to a product with more than one component. This is our bread and butter business, Euro decorative coated chipboard. It usually is set together by wood, either from fresh wood or from sawmill byproducts, or a high share of post-consumer material. This enters to 84%. 50% are fossil-based adhesives, and 1% is the paper that is used for coating the surface. And all those figures are the shares by weight which enters the product. But when we have a look on our scope 3 emissions, we find that the non-wood materials are responsible for nearly 70% of our emissions in scope 3. And when you remember, they 70% of the emissions, and they enter into the product with 15%. So back to our value chain. I talked a lot about the wood and how nice wood is, and the last 20 years the wood industry used it as it was a kind of soft cushion where we slept on, that we are using so much wood and everything is so fine. But since we know our scope 3 emissions, we know that we have to focus on our fossil-based additives. And I want to show you LCA data for such an additive that we are using to glue those wood chips together, to bake them to one solid board. There we need those additives. And this is a classic, like very classic additive. It's fossil-based, And so we only have a very high amount of fossil emissions and zero emission from biogenic, because it has no biogenic feedstock in this. And this is because it is the biggest lever for our journey. And of course, we are very curious when one of our suppliers announced to have a carbon neutral plant-based product. And of course, we assumed that it would be better than that, because they said it's carbon neutral, it's plant-based, and we were very curious. But because I know when we use such a product and we want to implement it into our carbon footprint calculations, our verifier will ask for proof. And so I asked our supplier to give us an LCA. And for me, it was just a matter of formality to request this product carbon footprint. But when I had this then in front of me, first I was speechless, because this is the result of this product carbon footprint of this new bio-based product, climate neutral. And as you can see here, and now you are all experts in interpreting those those tables, we have in the global warming potential total, indeed, we have 0.0 emissions. But when we look down, fossil fuels, the emissions from fossil fuels has more than doubled. Sorry. And I don't know if you remember where we come from. It was 0.5 kilogram. And now we have more fossil fuels. And the uptake for biomass growth overshadowed those increased fossil emissions. So that we have in sum, we have 0.0. And if you don't have a deeper look into those data, you won't see that. And I asked our supplier, what happened? What are you doing? Why do you have more than doubled fossil emissions? And then it turned out that this product was made of biogas. And for the synthesis for this product, they are using the energy. They used a lot of energy, and this energy was not regenerative. It was fossil-based, and because they used a lot of energy in this process, you can see the result. And with this product, when we buy and process this product, we would move further away from net zero, and our scope 3 emission would increase. And here you can see that a negative or a zero global warming potential total does not automatically mean that this product is carbon neutral or even carbon negative. So what have we learned from the wood-based materials industry today? Bio-based material is not automatically climate friendly. Of course, mostly it is, but not automatically. The transport and the choice of energy sources during processing have a crucial influence on environmental performance. The declaration of the sum value global warming potential total is not sufficient to assess the climate effect of a product. A separate disclosure of biogenic uptake is essential to unmask those fossil emissions. So that's why I tell you, go out, ask your suppliers for detailed carbon footprint data in which the global warming potential of the biogenic share is reported separately. So, with this sentence, I want to close my presentation, and I'm looking forward to your question on the round table.